Hello friends, welcome to ANLIST channel. Let us start part 2 of Cryogenic Pipe Flow Simulation for liquid nitrogen with CFD. Export this mesh model to CFD software.
Hello friends, I have opened this 3D model in Ansys Fluent. You can see the setup here. In general, the mesh, many tabs are there, so we are interested to check the quality of the mesh. Here you just click on this check. So now we got this done. Okay, so mesh looks good. Next important is unit tab. So many people are working different units, metric system, SI systems like. So here I will show you how to change the units. I want to use temperature in degrees Celsius unit. So click on these units, select this temperature. Yeah, it's already in degrees Celsius. So close it. Next solver type, it's a pressure base for this particular analysis, and absolute. So time. So I have choose this transient. So I want to see the flow properties with respect to the time. Next is gravitational acceleration. So we have to set up the value of gravity with respect to the direction of the flow. So here I have given this input here and output here, and you can see axis x, y, z axis. So you can see y in this up direction. So we are giving flow in this down direction. So we are giving this y direction minus 9.81 meter per second squared. Next, go to models, double click on it. Make sure energy is on because temperature is one of parameter in this analysis. If there is no temperature parameters in any analysis, make sure it's off. For this, you have to double click on it and check and uncheck. So here energy is on. Okay, next, viscous, that property of the flow. So viscous, different types of flow. Double click on. I choose the laminar. It's a simple laminar motion, laminar flow, and there are many other flow conditions. It depends your application, you can choose. Next, go to the materials. So any analysis, fluid and solid, we have to choose. So here fluid is air, solid is copper. So I already choose air from the database and solid and copper from the solid database. If you want to add any other medium, you can double click here, and if you want to add any other fluid, make sure this fluid and Fluent database, you can choose. Here also you have to make sure it's a fluid, and you can choose any medium, then copy and close, and make sure change the create and close. Similarly, you can choose the solid as well. Next is self zone conditions. Here is fluid domain and tube domain. I like to repeat this analysis about this reanalysis. It's a copper coil, air is flowing through the coil in particular velocity, and coil is immersed in a liquid nitrogen tank. So heat will be transferring from the top surface of the copper coil into the inner surface of the copper coil. From there the heat will transfer to the fluid, that is air. Okay, so we have to make sure this fluid domain, double click on it, air. See, because we have choose other medium also, so make sure it's air. Next is tube domain, make sure it's a copper. Okay, next go to boundary conditions, double click on it. You can see inlet, outlet, walls, domains. I have already defined the boundaries, which is there in the part 1. Yeah, so here you can see all defined walls and inlet and outlet, inlet of the airflow, outlet of the airflow, and the tube domain and fluid domain. Okay, so why this wall, different walls means all the walls is outside of this copper coil and inside surface of the copper coil, and the interface between uh, fluid and the copper coil. Okay, then back to the fluents. Next, we have to give the inputs. So for input, this inlet airflow temperature and the velocity. Just double click or click on the edit. The momentum, we have to define the velocity. Here I have given 0.5 meter per second. All depends upon your requirements. Even you can give different values. Next, thermal. So inlet airflow temperature will be at room temperature. So these values, it's a default value within the software. Okay, now outlet. Okay, outlet we have defined as outflow. Okay, next is we have to give the temperature on the copper tube. Since this copper tube is immersed in a liquid nitrogen tank, the surface temperature on the copper coil will be the temperature of the liquid nitrogen. That is, the boiling point of liquid nitrogen is minus 196 degrees Celsius. Here the temperature will be transferring from liquid nitrogen to the surface of the copper, then next to the air, the fluid domain. Okay. Next, go to solution. Click on the methods. Double click on it. So pressure velocity coupling. So I have chosen couple type scheme. You can say simple PISO coupled. So I choose the coupled one. Next important thing is monitors. Click on residual. All the residuals values make it to 10 to the power of 6. Okay. Next, initialization. See a standard initialization and hybrid initialization methods. So I choose standard initialization. So I have to start from inlet. Okay. And click on initialize. Next, run the calculation. Oh, the number of time steps I have taken, 10 steps, and time step size is 60 seconds. That means 60 seconds into 10, 600. It means 10 minutes. So profile update interval 2. That's it. Then click on calculate. After run calculation, the result will be looks like this. Here you can see the variation of the temperature of the fluid. Here is the variation chart of the temperature, but it looks not good interpreted in this interface, this Fluent interface. I would suggest to open the result in CFD post. Let me open CFD post. Okay, so I already choose one counter. Okay, so the counter and its result. I want to brief the result Here you can see the temperature of inlet temperature of the fluid will be 20 degree, right? Inlet. After cooling down while by passing through this coil, air temperature outlet air temperature will be around minus 100 degree. Okay, that's it. So even we can calculate the complete outlet temperature of the air. Hope you can play with these variables, expressions, etc. Point out the correct temperature at various locations. Actually, we are interested on the outlet temperature of the fluid, means airflow. Also notice we have done the transient flow. That means time dependent flow, right? So we have given the transient time of 600 seconds. That means 10 minutes. This result will be for a 10-minute airflow. So after some more, if you give more transient time, if you set the transient time more, then we can get better cooling of the air outlet. Okay, that's all, friends.
Thank you for watching our channel. If you have any doubts about this analysis, contact us by email analystcadkey@gmail.com or write message in comment box below. We are available for your any clarifications. If you have similar projects and you want supports from us, please let us know. Thank you, friends.